Hello, all the science enthusiasts out there. We members of Group 9 will tell you about an old tech known as vacuum tubes, how it works, and made lives easier in the past.
A vacuum tube is a device which controls the electric current flow in high vacuum between electrodes to which electric potential difference has been applied. Developed by John Ambrose in 1904, they were a key component in the electronic circuits during the first half of the 20th century. They were crucial for the development of radio, televisions, radar, long distance telephone networks, sound recording and reproduction, and early digital computers. By using vacuum tubes instead of mechanical relays, computers could move away from the mechanical switching and move up the switching on and off of electrons. Vacuum tubes were used in radios, televisions, radar equipment, and telephone systems during the first half of the 20th century. There are two types of vacuum tubes: thermionic tubes, in which electrodes are heated for the electron emission, which are then used for signal amplification and current rectification. Non-thermionic tubes, in which electrons are emitted using the photoelectric effect, which are then used for the detection of light intensities. Vacuum tube consists of two or more electrodes in vacuum inside a sealed envelope. The envelope was made of metal, ceramic, or glass with glass to metal seals. The electrodes are connected to the lead, which pass through the airtight seals and are connected to the pins at the base of the vacuum tube. These pins are then connected to the tube sockets to apply electricity to the device. Often, one electrode was connected to the base tube socket and other electrode terminating at a top cap to prevent high leakage resistance, to improve stability and high frequency performance. Starting with the diode, when electricity is passed through the vacuum tube, with the electrode at the center, which is the cathode, it heats up. This heating results in emission of electron via the process of thermionic emission. The second electrode, which was the anode, was a surrounding metal plate maintained at a high voltage than cathode. Due to the electric field in the direction from anode to cathode, there was a net unidirectional flow of electrons from cathode to anode. If the vacuum tube contained only two electrodes, that is, cathode and anode, then the tube was called a diode. If in addition to it, more electrons were added in the form of grids between cathode and anode, they provided more control over the flow of current, and depending on the number of electrodes, the tubes were further developed as follows. One of the type of the vacuum tube we know is triode. If we talk about the diode in the previous section, the electric current flows from high potential applied to the anode towards the ground potential of the cathode. However, a valve that allows controlling this flow is still needed. In a triode, as depicted in the figure, a third terminal, called grid, is placed between the anode and the cathode. When the electric potential of the grid is lower than that of the cathode, the electrons emitted by the cathode are repelled and find difficulties to reach the anode. If the grid is negative enough, current is blocked, obtaining the same effect of closing the valve in the switch. If the grid potential is same than that of the cathode, the current flows freely from the anode to the cathode, obtaining the same effect of fully opening the valve in the switch. Intermediate negative grid voltages modulate the current flowing from the anode to the cathode. When the voltage signal is applied to the grid, the electric current from the anode to the cathode follows the signal applied to the grid. Coming up next is the tetrode. A tetrode, as shown in the figure, has a fourth electrode called screen between the anode and the grid. The screen has the purpose of reducing the capacitance produced by the grid and the anode. In fact, in a triode, the grid and the anode are very close to one another and jointly behave as a small capacitor, which might cause instability and oscillations. If the screen has voltage higher than that of the cathode and the grid but lower than the anode, it acts as an electrostatic screen between the grid and the anode, thus reducing their inherent capacitance. Tetrodes were further refined with the introduction of pentode. When electrons emitted by the cathode reach the anode, they might have enough energy to stimulate secondary electron emission from the anode itself. Secondary emission electrons might reach the screen grid, causing instability and oscillations. In order to prevent secondary emission electrons from reaching the screen grid, pentodes use a fifth electrode called suppressor as shown in the figure. Suppressor is directly connected to the cathode either with an internal connection in the vacuum tube or by an explicit connection between the corresponding pins. In 1950s, transistors started to replace vacuum tubes as vacuum tubes were bulky, hence difficult and less suitable for portable devices. Vacuum tubes had high operating voltages, usually ranging from 6 volts to 12 volts, which is relatively high when compared to transistors. Glass tubes are fragile when compared to metal transistors and also expensive at the same time. As computing devices started to get smaller, transistors were more ideal due to smaller size. Today, vacuum tubes are used in high-end audio equipment preferred by audiophiles as an alternative to digital systems. Thank you.